All right, so we are live. So hi guys, my name is Ram from Great Learning, and today we're going to be doing a live session on Introduction to Git. So guys, we'll be talking about Git. So it's a version control tool, right? So we'll be talking a lot about it, like what version control itself is, what Git is, what is the Git lifecycle. Then I'll go through a lot of the basic commands that you guys will need to know. And if you're a fresher who's watching this video, then this session is really perfect for you because Git is something you can learn in like 10 minutes or even an hour. In an hour, you'll get a very good idea of what Git is. And this session basically pertains to that idea, right? Okay, so before I do start this session, there are a few things I need to tell you guys. And before that, I need to get a confirmation from you guys that, if you can hear me talking or rambling, whatever you like to call it, and if you can see my screen at all or not. So till you guys give me that confirmation, there's going to be a bit of a lag between me talking and me checking the chat. So till you guys give me that confirmation, I will go ahead and show you guys something. So here at Great Learning, we're a e-learning institute. We provide something called Great Learning Academy. So Great Learning Academy is an initiative that we have started for the COVID situation because a lot of people have lost their jobs and a lot of people can't find jobs that easily. So this is something that will definitely help you out. So Great Learning Academy is a place where we provide more than 80 plus free courses, and they're completely free, guys, and you get a certification at the end of it. So you just head to greatlearning.in/academy and you will see a lot of different courses that you can start with. Python for machine learning foundations, introduction to R, data visualization, cloud foundations, and even digital marketing. And this is not just it, you have a lot of different domains over here. If you want to check full stack out, you can go to software development over here and a lot of different things. All right. So if you're interested, please enroll in these courses. They're around 3 to 6 hours. And once you complete it, upon completion, you will get a certificate. So that will definitely help you out also. All right. So once again, Great Learning Academy on Google or greatlearning.in/academy. Okay, now I'll check the chat to see what kind of response I'm getting. All right, so we're getting a good amount of response. Yes, yes. So hello, sir. Hi, hello. And we have someone putting in, yes in Korean, I assume. All right, so that's pretty good. Someone's asking for Hindi. Well, Yogendra will do Hindi session later. This is going to be an English session, but I do, expect you to stick around. That would be fun, because if you understand Hindi, then you'll understand a lot. So there's someone asking a question. Karna, yeah, hi Karna, hello. Oh, I see you're from class 8. Oh, nice. All right. So we have some young people over here. So that's really good. You're looking for your future. So guys, right now, let's start this session. So Git is for a lot of different kinds of people. If you are going to be coding, and I assume a lot of you are going to be coding because coding is really the future. Like even with the new NEP, the new education policy that's been instilled, in country, and not just in India, a lot of places across the world, you have a lot of people, learning coding, and coding has become something really ubiquitous. Like a lot of people are doing it. Not just, your software developers. You have students, you have researchers, you have professors, you have, software developers, data scientists, and some people even use Git for other purposes, like, organizing the data and everything. So that's why the session is there for to teach you guys how to do it. So let's quickly get started. Let me show you what we will be going through. So first I will tell you guys what version control exactly is, because some of you may not know what version control is. Then we'll understand why do we need one. Now I'll quickly browse through these topics. Then we'll see what are the different version control systems available. Then we'll talk about Git overview, where we will go into detail about Git, like what Git is and why do we need it. And we'll talk about the Git lifecycle and everything. Then I'll teach you guys, about GitHub, what GitHub is, how it will help you out. And then we'll learn how to install Git and configure it. And also we'll be learning a lot of basic commands about branches and merging. If you have time, we'll go through merging and Git workflow also. All right. Okay, so now let's get started by talking about what version control is. So can I get an answer in the chat? Can somebody tell me what version control is? Even one answer would be totally fine for me. how do you define what a version control is, or what is this term version control? I want this chat to be very lively. I want people to answer back to me. I want this to be like an actual classroom. So we have someone from kindergarten also. That's really nice. All right, so I like what Shiv is saying. Shiv is saying when you change something in code, and even Avika has said changes from one code to next. So the ideas that you guys are telling, it's like that. Yes, different versions of something. So like Sandeep says, different versions of a software product. So that is true. But when I say version control, this version control is not just dedicated to our software. Version control is like how you version certain things. Obviously, in our context, when we talk about Git, we do mean software. But when I say what is version control can be in any part of your life. You can have different versions of certain things, not just software. Let's say that you are an artist and you like to, you do quick paintings. You're a graphic designer. Let's say you're a graphic designer. Now you sent a first version to your client, and the client is like, I like it, but I don't like it that much. Can you make it bigger, or whatever requirements he has? He tells you again. So you come up with the version 2. So that's where you have a lot of different versions, and you need to control how you store those versions and how you organize those versions. I see that the chat is very lively. People asking questions also. Whenever we are making changes to code, we have a new version of a project. So to maintain older versions and identify errors. Yeah, Pratyaksh is totally right. So that is what we do for software, and that is version control, where we try to keep the different versions of certain things. It can be a product, it can be any kind of service, in a certain organized manner, so that we can always go back and check out our older versions or the most stable version or whatever category we want to check out. So that is what version control is. So these days, when we develop software, right, it is not developed with the mindset that there will be only one piece of code. Maybe as a student, when you code, right, you won't think of having multiple versions. You will think of just coding your project and giving it to your teacher, and that's it. But these days, right, smaller snippets of codes are deployed in regular successions with regular feedbacks. So when you deploy software, like a lot of you have already told me, you deploy the software with thinking that you will have multiple versions of it, more improved versions that you will make when you get feedbacks from your customers, from yourself, from your teammates, and improve your software and you deploy it again. So this leads to having many different versions of your software or code. So, and that creates a need to organize this code and all of its different versions. So let's take an example. Let me give you an example of a college student or a school student. Now they have a deadline on the 30th of September, and on 29th of September they have finished their project. But they think that the project, is not the best thing that they can make. They won't get an A grade. They'll only get a B grade. That's what they think. So they decide to change the project. They decide to, make it A grade worthy, so that next day when they show it to their professor, the professor is like, yeah, this is really nice and I'll give you an A grade. But the thing is that they don't keep in mind this version control factor. What they do is they override their old code. And while they override the old code, they take 4 or 5 hours to override their old code and make it much better. They execute it and they see that it's not running. And now they don't have any more time. What do? Do they panic? Well, obviously that's not the scenario. But the solution is not the point over here. The point is, if that person had, organized his code, kept the older versions before and kept the new version in a separate place, or at least backed it up, then he wouldn't be facing such a kind of a problem, right? So that's why we need a version control. And this is especially the case with larger companies that have multiple projects. Let's say Google, Microsoft, these big companies, right? It's even hard to imagine how many developing teams they have and how many people they have working under them. Let me give you a smaller company, a smaller startup. Let's say Tesla. Now Tesla is a big company, but I'm pretty sure they have the software development team is a little bit smaller. So over there they have multiple projects, right? And they have multiple teams working within them. So let's say they have project A, they have project B, they have project C, and all of these projects have their own versions. Now, these versions and these projects will be handled by different teams. Like project A is handled by team A, project B is handled by team B, project C is handled by team C, and all of them have their own different versions. So this way you can see how many types and how many versions of software we have. So there comes a need to make sure that all of this is organized, because what if you want to go back to an older code, if you want to go back to an older version because you think your new version is not working. So let's say team A deploys the latest version of their project A, that is A3 version, and they see that the A3 version is not working as well as they expected it to. But they can't remove the service because the customer needs to interact with the service, and if there's any downtime in the software, then they won't be happy. So to make sure that they never feel this kind of inconvenience, they actually remove A3, but then they quickly replace it with A2 because they know A2 was the most stable, at least the most stable previous version. So that's what they do in this scenario. All right. So guys, this is why we need version control, and this is what version control is also. So coming back to same thing as I said earlier, just as we discussed, the purpose of version control system is, as the name suggests, it controls different versions of the code. It allows for quick delivery of code and automatic job triggering. This allows for easy automation of the whole software development pipeline. So that's why we need version control, because when you have to develop software using any kind of methodology like DevOps or Agile, you have to develop this software in quick succession and as efficiently as possible. You do it with the help of a software development pipeline, and to integrate yourself the development part to the software development pipeline, you have to make use of a version control system. All right, so you'll understand what I'm talking about when we go into deeper. All right. Okay, so let me just quickly glance through the chat. I see there are a lot of messages. Some of you may have any questions. Yes, Vidya has given a very good example. It is similar to different versions of operating system of Windows. I've used this example before. It didn't come to my mind, but thank you for reminding, Vidya. Yeah, like you have a lot of different versions of Windows, right? The ones that we remember, like from XP onwards to, or at least I remember, XP, Vista, and you had 8, 7, 8, 8.1, and then they came up with 10, and who knows what they're going to come in future, but they have these different versions. So controlling how you release them, how you store them, what you do, plan for the future, all of that comes under version control. All right. So, guys, feel free to ask any questions if you have in the chat. I'll try to answer them. All right. So let's moving on. Benefits of version control system. So we have like a lot of different benefits of version control. So one of them is control itself. So controlling how your code works, what kind of code you're going to be deploying, how you're going to fine tune it. Are you going to be sending that specific code for deployment, or are you going to wait for other branches to join in and send that in, and basically how you design the whole thing. So that's what comes under control. Then is security. So when you're using a version control system, you are forming a layer of security over your software development process. Because you're using a version control system, only authorized people can pull and push certain codes to your remote repositories or the location where your main code is. And that way you don't have any unauthorized access, and you don't have people coming in and stealing any of your assets, that is your code. So that forms a layer of security. And then fast delivery, as I've talked, any version control system should be able to mesh really well with the software development pipeline, so that you can push code and it gets deployed and delivered very fast. That is again an important thing in today's developing industry, right? And availability. Now availability is something only certain version control systems have. Those are your distributed version control system that are not in like one location, but rather on a lot of different places. So they provide you with this availability thing. So Git, let me take the example of Git itself. So you have Git and GitHub. GitHub is where you store all of your different versions of code, and you can access all of these different versions of code from anywhere in the world. Doesn't matter where you are, or doesn't matter who you are. If you have access to internet, and if you have access to a certain repository you can definitely pull that code and start working on it. So that talks about the availability. This is important because especially during this pandemic, right? We are in a situation where it's very difficult for people to come and meet each other, or it's very dangerous for this to happen. So this is the exact opportunity where availability comes in. You don't have to go to your office to get the code, or you don't have to wait to go to the office to share your code with your team lead or your senior. We are so connected this world that we just have to get access to our remote repository where that code is stored, and we can pull it. So that talks about availability. So these are the different benefits of a version control system. All right, so now let's quickly glance through all the different version control systems there are. So we have AWS code commit. That is AWS's own service. If you're using AWS, then you can make use of code commit. Then you have Git itself, and then you have Mercurial. So if you guys know any other version control systems, feel free to tell me in the chat. These are the ones that I'm more know about, especially Git. All right. So in today's session, we'll basically be learning about Git. So if you're Sherlock, you must have reduced that pretty well. Okay, so Git overview. So what is Git and why do we need Git? So first thing, what is Git? So Git is an open source version control system that allows users to keep track of all the changes that have been made to the source code or software. So basically, it's a version control system that allows you people to just keep track of what kind of changes have been made to their code and what has happened to it. Has it been pushed or pulled, or who has worked on it? All those kind of things. So Git helps you track your code basically, and Git, it does not work alone. Git works as a two-man team. You have Git and you have GitHub. So the developer, right? The developer, let's say they're developer 1 and 2. They finish writing the code and they push their code to GitHub. So what is this pushing? So developer 1 and developer 2 will have the codes on their local systems, and they'll track it by using the Git tool. Git tool is the one that does all of the actual, tracking, all the saving the changes, and basically it acts as the second part. So when you're done doing all the work on your local system, you push it to a storage location. So GitHub acts as your storage location where you store all of your code. So you will be making those changes and you'll be saving those changes with the help of Git, but you will be storing it in GitHub. So GitHub is your dedicated storage location. Sorry guys. All right, so GitHub is the place where you store all the code. So if you ever see someone talking about Git, you'll always you will hear about GitHub also. They'll be like, what's your GitHub repository? Can I just fork it? I want you to see your code, check it out, or maybe use it in my software. So when they talk about that, they're talking about using someone else's code from the URL on GitHub and copying it into their local system, right? So that's what Git is. Now from Git, it can go to any place. Like if you are working with software development process, it can go for deployment. It can go to building process, or it can be tested, and then it can go for deployment. All right. So this is what Git is. Now Git was developed. I'm not sure of the year, but it was developed like back in 2000s. Linus Torvald was the one who developed Git. So if we just come back over here. Yeah, so I was right. So Linus Torvald is the one who created Git, basically. Now, him and a bunch of his buddies came together to build Git because Git was something that they needed back then. Back then, Git was not. See, Git is an open source tool. That means it's a free tool, and it has a lot of amazing features that people can make use of. But back then, they only had they had only paid version control systems, and the ones that weren't paid weren't as good. So they made Git because they wanted open source software that allowed people to do it. And after they made Git slowly started gaining popularity because of a few reasons. Like one of the few reasons was a Git is really fast in replicating repositories. Git has really good security, and it has very good collaboration ability where a lot of different people can work in a hierarchy without having any issues, and that it's free. So that attracted a lot of people, especially hobbyists who wanted to, basically code but not make use of paid services, or startups. Startups generally don't have that many resources or that much capital, so they don't want to accrue even more subscription costs. So if they can avoid it someplace, they will, and that's why they started making use of Git. So slowly, slowly, Git became really, really popular, and today Git is like this industry standard. Obviously, not everyone makes use of it. Some companies still have their own legacy version control systems that they're still using, like SVN, or if they want to make use of something else like Mercurial or AWS Code Commit for certain requirements, then they make use of it. All right, so that's about Git. Now I want to show you guys the Git full form also. If somebody asks you what Git full form is, right? So Git full form is oh, okay. Yeah, Global Information Tracker. That's right. Git's full form is Global Information Tracker. Sorry, just slipped out of my mind. All right, so now let's talk about the life cycle of code. Now, you guys probably understand how code is being, how code goes through the Git. Like you basically have code on your local system, and when you're done working with it, you push it to a remote repository, a remote storage location where you can store your code from where it can be pulled to any place. That's like the basics of it. But how does it actually happen? What is like the life cycle of code within Git? So there is a few steps that we have to know about. Like the first step, that is assigning a working directory. So this is something you do within your mind, where you assign a working directory for yourself. As the name suggests, is the directory where you're working. So if I go to my desktop, and you guys can see my really cool wallpaper, and if I open Git over here, so let me open Git bash. So you guys can see that this is the desktop directory, and this is the location. If I decide to work on the desktop, then the desktop will be my working directory because I've assigned it so. Now I'll put all my code inside of this directory. Now a directory, if you don't know what it is, it's basically like a folder. It's a location where you put all of your different things. So that's assigning the working directory. Now once you're done assigning your working directory, you go on to the next step, that is initialization. So you perform a git command that initializes this working directory. The initialization process basically tells Git that this is the repository that you'll be working on. So in the second step, you're basically telling Git that this is my working repository, or this is my working directory. So please assign it as my local repository. It is going to be different from my remote repository, where remote repository is where all my main code is going to be there. But in local repository is where I'm going to be working, and I'm going to make all the changes, and etc. So that is the initialization step, where you tell Git that this is my working directory and this is to be considered as a local repository. So Git will basically understand this, and he will start tracking all of your files, like if there are any files inside here or not. And once the initialization has completed, then your staging process happens. So staging here basically is telling Git that I've made my changes. So between initialization and staging, you'll do all of your work. If you want to add in new files, you'll add new files. If you want to delete any files, you'll delete any files. Or if you want to make any changes to your code, you make any changes. And this will happen between initialization and staging. So once you're done initialization, you will start working. And once you're done working, you'll stage whatever you want to. So staging basically tells Git that this file has to be tracked. So it will then individually go to that file and individually check that file for what changes have been made to that file. So it will see if there are any deletions. It will check if there are any additions. So it will check all of those things in the staging part. And once you stage that code, you can go ahead and save those changes. To save those changes, you do a commit. And that comes to a local storage part, or your committing part. So that's your fourth part process of part of your life cycle, where you're committing all the changes you made. When you commit a change that you made, you do it in a local repository. So that's why I've written local storage over here. And once you've done committing all of your changes, that means all of your work is done. You will go ahead and push it to a remote repository. So this can be a GitHub. So a good example here would be like, let's say you're working for a software development company where they're developing a certain software, and they've asked you to make a feature. And what you will do first is you will get the code, whatever main code there is already, you will pull it to your local system, and then you'll start working on it. So when you start working on it, you do all the changes you want and everything. And then you stage that code. So you will see that you will be over here and then you stage that code. Once you stage that code, Git will basically start tracking whatever changes you made. And once it tracks all of the changes you made, it will ask you if you want to commit it. Well, basically, you will have to personally commit it. And once you commit them, all the changes that you've made to that thing where you've created a feature will be saved. And then you can go ahead and push it back to GitHub. So the whole cycle keeps on repeating until the end of the project. All right. Okay, so this is the life cycle of Git, where let me just go through this again, where you have the working directory where you assign a working directory. Then comes the initialization phase where you initialize, where you tell Git that this is my working directory, please assign it as a local repository. Then you start working on your code, and after you're done working, you stage that code. So this will ask Git to check the changes you've made, and once it checks all the changes, you will ask it to save the code that is committing, and once you've committed all the code, you will push it to GitHub. All right, so this is the life cycle of Git. Okay, so before we move on to the next part, that is getting started with GitHub, guys, please feel free to ask any questions. Did you guys understand what the lifecycle was? Also, I'll just go through the chat. There's a lot of messages. Is it similar? So Vidya asks, is it similar to different versions of operating systems of Windows? See, version control is that, but a version control system basically allows you to control different versions of a code. I just want to tell you the definitions term. What is version control? When it comes to context with software, and we're talking about version control system, we mean having different versions of certain code of certain software, right? So it's different than having different versions of your Windows, because you won't be storing the different versions of your Windows in a local repository. This basically helps us to organize our code. This is like an organization tool. So someone's asking, Abhishek's asking, what is automatic job triggering? So jobs are like processes that you want to execute. Let's say you want your code to be tested. So you will create a job. In that job, you will mention what you want to be done with your code. If you want your code to be tested, you'll mention that in a job. And that job will be automatically triggered if you set a certain condition. Now, beyond this, if I go into it, it will take a long time. So if you want to know about automatic job triggering, please go ahead and check out my Jenkins video. It'll give you a better idea. So someone's asking about GitLab. Now, GitLab is a little different than Git and GitHub. GitLab is something, it's for continuous integration purposes. So that it basically allows you to develop your software as a whole. Like it has everything. It has version control system. It has continuous integration. It has deployment. So you can do all of that in Git. Someone's asking, can we say GitHub as a database? See, yeah, I mean, you can say that GitHub is a database. Not exactly. In database, you do a lot of different things, but you can imagine it like that. But never tell anyone that GitHub is like a database. All right, so I understand people are saying that they understand everything. Okay, so guys, let's get started with GitHub. Now, basically, I will open up an incognito tab over here because I want to show you guys how you can create an account. Just type in github.com on Google or your navigation bar, and it will take you to the main page over here. Now, it tells you that it's built for developers. That's definitely true. So you have two options: sign up or sign in or sign up. If you guys are new to GitHub and if you don't have a GitHub account, please sign up. Just type in whatever username you want to, or email and password, and sign up for Git. It's a very easy process where you just do a simple a verification that you're not a robot, and it will send you a verification email. You just click on the link that they give you, and you have your email account created. Now I'll directly go to the process where I show you my GitHub account. All right, so this is my GitHub account over here. And you guys can see there are a lot of things. These are my repositories over here, and this is my homepage. Now, if you click over here, you can see my profile and repositories and projects and everything. Now, what I want you guys to learn is how you can create a GitHub repository. Now, repositories are basically storage locations. You can have repositories for a lot of different things. You can have image repositories that will store images. You can have video repositories that store videos. And you have code repositories like Git that store code. So yeah, It's a data storage location. Now we will click on new over here. You will see new regardless of, you are a new guy who signed into his new account, or if you already have an account, you'll see that new option over there. And this will allow you to create a new repository. A repository contains all project files, including a revision history, and already have no, so this is not needed. So it basically contains all the project files. So if your project requires a lot of images also, then you can store the images also within Git. Now over here, my owner is going to be my username itself, and repository name, I'm going to put something from the chat. Let's say, yeah. So actually, I'll just give it a generic name. So let's say this is my repo. Now this is a very generic name. So my repository is going to be the name of my repository. Or actually, you know what? A better practice would be to give a repository a relevant name. Now, this is a standard better practice that you guys should also follow. Give it a very relevant name. So let's say if I'm going to launch a HTML project, right? So I'm going to type in over here HTML sample live session project. So this is going to be the name of my repository. So it's easy for me to understand and easy for me to search for this also. Okay, and then you have the option to give it a description. Now this is completely optional, but you should give a description. It's nice. If somebody else checks out your repository, please go ahead and give this a description, but I am going to avoid it. Over here, guys, you can choose to have this repository public or private. Now when you do public, right, anyone can see your repository. So any of my public repositories can be viewed by you guys also. So I'll leave it public to show you guys, you can access it also. And private means, you basically choose who can see and commit to this repository. So even in public, no one else can commit, only you can commit, but everyone can see. But in private, no one can see it also. So this means that if you ever wanted to access this repository, you will need to give your credentials of your username and account password, even on your local system. But we'll leave it public because I want it so. And you can add me a readme file or a .gitignore file or a choose license file. So a .gitignore file basically contains all those files that you don't want to track. Now this you guys don't need to concern yourselves with this. It's for something to learn later. Now a readme file is basically a very long description for your file. All right. So you can add these, and you can choose to add a license. If you want to tell people that you can only use my code in a certain way, then you can choose to add what kind of license you want. Now I can choose a license to be Apache license, GNU license, whatever license I want. All right, so I'm not going to choose these because we don't need this right now. I'm just going to click on create repository. So it's as simple as that. Just give your name and make sure it's public and create your repository. So this is your repository, and you guys can see it's giving you steps to do things like create a new repository on command line. You can copy these commands and do that, or push an existing repository on command line. All right, and the main thing you guys need to concern yourselves with is this. So this is the URL of your code. So you can copy it and keep it. So this URL is basically going to be your access to this repository. So you can access it anytime you want using this URL. So if I go to the browser and I type, paste in the URL, you guys will see it will directly take me to my repository. Now it's not showing anything in code because we haven't actually pushed any code. So let's go ahead and change that. Let's add a code over here. So now to do that, right, we will actually have to learn about GitHub, Git commands. All right, so let's move on to the next topic. That is basically installing and configuring it. So I assume a lot of you have Windows and not Linux, because I will be working with Windows Git over here. But the Linux Git process is not that difficult. I'll tell you guys how to install Git on Linux also. It's very simple. Let me just open up a text file. All right. Okay. So over here, guys, basically you just need to type in sudo apt update and sudo apt install git -y. If you guys are using Ubuntu, then this is the command for it. All right. It's as simple as that. Then you can start working with all the git commands. Now Windows is a little bit different. Let me just close all of this. All right. Now, okay, so we will download Git for Windows. Just type in Git for Windows on your browser. The first link that comes in, click on that link. Git downloading package, Git SCM. So basically, it will start downloading Git for you, but this is for 64-bit version of Git. Okay. So if it doesn't download, you can just click over here to download manually, and you guys can see that it's downloading Git. All right, so we'll just wait for this to finish. So Prem is asking, is the command same for all Linux distros? No, it's not same for all Linux distros. If you want to do it with RHEL or CentOS, then you have to use a different package manager, where instead of apt, you might have to use yum. All right. So if you want to learn for other Linux distros, you go ahead and just type in Google. You'll get the answer. All right. So let me just open up Git over here. So this is my installation wizard where I click on yes, and it will allow me to install Git for myself. All right, so William has a question. I have a question. What about in case whereby you are working on a very private work like self-driving cars, and are you not exposed to people stealing your piece of code and cloning it? So that's what. If you make your repository private, but I assume when you're working with that kind of the secret project, you're working for an organization, right? So organizations have their own GitHub thing where you have all the different types of authorization for that. But if you're someone who's working on a secret project for himself and you don't want to show it to other people, just choose the private option. When you choose the private option, anyone can't view the not everyone can view the link. Only those people who you give the access to, right? So that's where the whole privacy thing comes in. Yeah, thank you, Ankit, for helping me out over there. All right, so we have a Git installation. So let me just show you guys. This is what will appear. Just click on next. Keep on clicking next. You guys don't need to change anything over here. Seriously, if you want, you can choose different notepad. I'm gonna leave it for Vim. If you're especially a beginner, I would recommend leaving everything default as it is, because there are a lot of different features that you can enable. Just keep on clicking on next and install. Setup cannot continue until you close at least one of those applications. Is required closing. All right, so it's telling me to close some things, but I can't figure out what is closing. Okay, so it requires me to close my bash terminal that I already have open. Let me close that and let's install. All right, so it's started installing for us. Now, hopefully this doesn't take too long. And while it's happening, you guys can ask me questions. Okay, Abhishek asks, how some of the projects has own username to the code software? Is it allowed to have multiple accounts for different projects? Yes, you can have different people working on different projects, Abhishek. That's whole the collaboration thing, especially in an organization, right? Uh, you'll have a lot of different people working on same repositories, same main code. So you can have different owners for it. All right, so now we have Git set up. Now just click on launch bash because, all right, so I won't launch bash because I'll show you guys what else is there. All right, so we have installed Git, and if you come to your main page over here, like I have, just you can right click and click on Git GUI here or Git bash here. So the difference here is that Git bash is basically a bash terminal. It's like any other terminal that you use in Linux, like a bash terminal that you use in Linux. If you're using Ubuntu, you use this. And you have Git GUI over here. So this is graphical user interface. So let me just show you quickly this, but we will be working with bash. I'll show you guys that. So this is if you want to use a UI with your Git, or else this is an option for you guys. If you want, you have an option to commit and push over here, but I don't really work with this. Cancel. Okay, over here, since I'm using Sublime over here, you have an option to get Git for Sublime also as a plugin. You can go ahead and do that. All right, so now what we're going to do is we're going to open Git bash. So Git bash is where I'm going to teach you guys all the commands. Okay, so Git bash over here. All right, so the first command, first thing I want to tell you guys is we'll be following the lifecycle, the code lifecycle that I showed you guys. So we'll be basically assigning a working directory for ourselves, initializing, staging, local storage, and GitHub. Okay, so we have created a GitHub repository. So we don't need to worry about that. First, we'll assign a working directory. So let me show you the bash thing. So this is basically a username and everything, the compiler, and this is the directory where you are in right now. Now, if you want to change your directory, you can go ahead and create your own directory. You can use a command called mkdir. It creates a directory and name that directory whatever you want. So let's say this is my live session project. So I'm going to create a directory with this name. And once I create this directory, I can check with ls command. So ls command will list down all the files in your desktop location. So right now I have live session project and all the other files. So let me go into this directory. So I will use the command cd for this. So cd allows me to go into directories. So I will type in cd live session project. Okay, and then I'll press enter. And you can see that the directory has changed from desktop to desktop live session projects. Now what I will do is in my mind I will assign this as a working directory. So this has now been assigned as a working directory. So basically we finished the first step. Now what we're going to do is we're going to initialize this as a local repository. To do that we need to type in git init. Now git init basically allows you to initialize your repository, local repository. And then we're going to go ahead and press enter. And you guys can see that it tells us initializing empty git repository in this location. All right. So we have initialized our repository. So that is a first step. So now we'll track all the files. So we can go ahead and create a file. So let me type in nano index.html. If I do this, it will open up empty index.html file. So nano over here is basically an editor. It's a text editor. So if you type in nano and whatever text file, then it will open it up in a text editor. Now I can type in anything I want over here. So let me just write a quick code. All right, so this is a very quick code. Hello guys, let me go ahead and save this. So this is my index.html file. If I do an ls, I can see my index.html file. Now you want to see if basically these are being tracked or not. We'll be using git status for that. But guys, so next step is basically staging. So we've made our changes. We've worked on our code. Now this is a simple thing, but just assume that we've worked a lot on our code. And our next step is basically staging. So to stage the file, we use the command git add. And we write the name of the file. If you want to write index.html, just write index.html. Whatever file you want to stage, you can stage it. But if you want to stage everything within the directory, you can just go ahead and type git add dot. So both things work. Let me go ahead and do git index.html. All right. So this will index my, this will stage my index.html file. All right. Now that we've staged the index.html file, that means it's tracked all the changes and everything. So let me go ahead and do a git status. And when we do git status, it basically tells us what the scene is. Like it will tell us how many commits, like what is the working tree clean or not. So it tells us that on branch master, no commits yet. So this means that there are no commits. We haven't saved any changes. Changes to be committed. So it's tracked the changes. Now it tells us that you need to commit these changes. That is, a new file was created. All right. So now let's go ahead and commit this. To commit a file, you need to type in a git commit -m and quotation marks, double quotes. Now, what is this command doing? So this command is basically committing all the staged files. So right now we've only staged index.html, but if we have staged every file within this folder or directory, then it will commit all of those files, basically save changes for all of those files. But right now it will do it only for index.html. So let's go ahead and write a message. So this -m basically allows you to write a message over here. You need to write a message, and always remember guys, write a relevant message. So I will write created a new file called index.html and added code in it. All right. So this is your message that you need to write, or whatever you want to write, and press enter. So this will go ahead and commit the changes. So this is my commit message, and it will tell you what changes have been made. So 1 file changed and 4 insertions. So this is for whatever code we added. All right. So guys, this is basically our saving changes in our local repository. So if I do a git status again, you guys will see that on branch master, nothing to commit. Working tree clean. So this means that we have basically made all the changes. We have saved the changes. Now we can go ahead and push this code onto our remote repository. All right, so to push it onto remote repository, what you need to do is you need to tell Git where you want to push it. Now, to tell Git where you want to push, you need to go ahead and copy the URL. So let me go ahead and copy the URL. Okay, let me open up my repository. And you can see that this is the one that we created, live session Git. And right, so it automatically added. Okay, one second. Right, so that is a different file. We created HTML sample live session project. That was from my previous session. All right, so this is a repository. Let me copy this repository. I'll come back over here. And what we will do is we will tell Git that we want to push to this repository. To do that, we will type in the command git remote add origin, and we'll paste the URL. So this will tell that the origin is going to be this. All right, let me press enter. And this will basically add this URL as our origin. So if we push to the origin, we will see that the code has been pushed to the origin. All right, so if you want to push your code, just type in git push origin master. Now, what does this command do? So this command basically pushes files to origin from master. So this is your destination and this is your source. Now in source, it will only push the committed files. All right, so let's go ahead and press enter. So you will see that, it's pushing, the process is happening, and it has now pushed your file onto GitHub. So if we go to our repository and if we refresh, we will see our index.html. And over here, you guys can see the commit that I've created also. So guys, this is basically the whole process of, pulling and pushing your file. And here we have learned how you can pull and push your basically we can push our file. So index.html has been pushed. You can go ahead and click on index.html and see your code. This is the code that we wrote. And if you come back over here, you guys can see your commit. If you click on your commit over here, you can basically see what happened in the commit. There were 4 insertions. All right. So you can see showing 1 changed file with 4 additions, 0 deletions. Now if we come back over here and if we click on commit over here, 1 commit. So this basically shows you the history of commits. So let me quickly go ahead and make a change. Right now it's showing that there's only 1 commit. We can go ahead and add more commits. To do that, first I will edit my index.html file. Let me add another tag over here. That will be my p tag. I'll be like, what's up? This is my controversial opinion that I'm writing. Don't leave any flaming comments. Let me save this. All right. So now basically we have added the changes. Now what we need to do is we need to stage this file. So I will go ahead and stage this file. So I will use the git add command. So I've staged it. Now Git will start tracking the changes, and I will go ahead and add a commit. All right, now I'll commit it. So it will commit all the changes. There was only 1 insertion and it committed it. Now on your system, how will you check how many commits do you have? So you can go ahead and use the command git log. It will show you all the commits you have. Right now we have 2 commits, that is this commit and the first commit that we did. All right, now that we've committed it, we need to go ahead and push it because it still won't reflect the change over here. So if I do git push origin master, now it will start pushing. And you can see it's pushed the code. So if we come back, if I refresh over here, okay, I have someone who reflects my opinions over here. All right. Okay, so over here it says added a controversial opinion in file. So this is my second commit. So you guys can see the history that is happening over here, the history of commits that are happening. So this way you can easily identify who pushed the code, who did what change in your code. So this allows you to identify and investigate if there any issues happen. And that is very important when you work with software development. Investigation of issues that have happened, try to resolve them, make sure that they don't happen in future. So if you go to HTML sample live session file, you guys can see that the new change has happened because the new commit is over here. It tells you 2 commits. If you click on index.html, it will show you the change that you have made. All right. So this is our basic Git. So if you guys have basically gone through this, you know what Git is. You know how you can use. It's as simple as this. If you want to work for a school project or college project, I would definitely recommend you guys to use this. Work with Git, because in future you will be working, so it's better you get practice before. All right, so somebody has a question. Ankit has a question. Please explain head, sir. All right, so let me go ahead and explain head to you guys. So when I do a Git log, right, it shows me all the commits I have. So it tells me a lot of different things about the commit. It tells me the author of the commit, it tells me the date of the commit, and it tells me the message that I've added. But it also gives me the commit ID, and it tells me head, master. What is this? What is this? We don't get what this is. So head is basically pointing to the latest commit. So you need to so master, right, it's a branch. Now the concept of branch, so for those of you who know the concept of branches, when you have multiple branches in your commits, right, you will have the different branches pointing to different commits. This happens when you have certain features behind in commits. Okay, to explain this, let me just explain branches. So what we will do is, I will go ahead and quickly explain the branches concept to you guys. So basically, you've done all the common commands. We were going to go to branches anyway. All right. Okay. So over here, branches, right? So branches are basically like timelines. So whenever you write code as software, right, it is very difficult for everyone. So let's say there are 10 people in your software development team and they all want to work on the main project. But the thing is, you can't directly keep on pulling and pushing from this code directly, because there needs to be intermediate layers or intermediate branches where you push or pull your code from. This is because the main code should not be affected. Only after rigorous testing or rigorous reviewing, the code should be put to the master branch. Now, master branch is where all the code will be pushed to the deployment side or the other processes of software development. So let me show you the diagram. It's much easier to show you the diagram. So this is the master branch. You can see that we made 3 commits over here. And from this master branch, what someone does is they make a secondary branch called feature 1 branch. So they create these feature 1 branches to make changes to the master branch, because you won't directly make changes to the master branch. You will make changes by pulling the code, making your own changes in your own branch, and then merging that branch back. So this is very useful when you want to create different features. So for example, let's say your team is working on delivering a website. This website will have different features, right? Like you have your payment feature, you have your tracking feature, your map feature, or whatever feature you add, like shopping cart feature. Each of these features will be counted as a branch that will be merged onto the master branch. Now, this is because you'll have different people working on different features. So they don't need to disturb the master branch. What they will do is they will just pull the master branch code. They will make their own branch. Let's say they make feature 1 branch. They write their code within feature 1 branch. And when they're done writing their extra code, they will merge it back to master. All right. So this can happen again and again. So you have feature 1 merging to master. You have feature 2 merging to master. So let me go ahead and explain this in the code itself. So let's say right now we have only index.html, but what if somebody wants to add like another .html file, a second developer? So they first will check how many branches there are. So if I do a git branch, it will tell me what all branches there are right now. So if I do git branch, it will only show me master. What if so if he wants to add new code, he will go ahead and type it git branch feature 1. So this creates a new branch called feature 1. So if you do git branch again, it will list down all the branches, and there is a new branch called feature 1 branch. And right now we are on master because it's highlighted over here and the star is over here. But if you want to switch to feature 1 branch, right, we can go ahead and do git checkout and the name of the branch that we want to switch to. So if we do a git checkout feature 1, we'll switch to branch of feature 1. And if I do a git branch again, you will see the change. You will see that feature 1 is over here and master is the one that we are no longer on. But if I do an ls over here, you can see that the index.html file is still here. Now why is it still here? We created a whole new branch. The code shouldn't be there. So this happens whenever you create a branch from a certain branch, it will copy all of the elements from that branch. So if we had created index.html within master, and when we created a branch from master, it copied all the elements from master onto feature 1. So that's how it works. All right, so here we have index.html. Let's say this developer is going to add his own file. He will add his own file called feature 1 dot am I spelling feature right? feature1.html. So he writes code for feature 1. All right, so this is his code. Let's assume this is his code and let's exit. Now what he will do is he will do the same process. He will stage this file. He will go ahead and commit this file. And he's done. But if he wanted to come back to master, right? See, if he goes back to master, if I do an ls, you can see index.html is only here. This is because he made the change on feature 1. So I hope you guys understand now that you can make changes on different branches that won't be reflected on your master. This way you don't disturb your master, but you're still making changes to it. Now what happens on feature 1 is, so this developer, right, he doesn't directly push it to master. First he will ask his senior developer to come and check it out. He will check the code, and if he approves the code, only then will he go ahead and merge this branch. So to merge the branch, we make use of a command called git merge and the name of the branch you're merging from. So if you're on master and you want to merge feature 1 to master, you will type git merge on master and write in the name of the branch you want to merge from. So basically we do git merge and you will see that it merged a branch. And if I do an ls now, we can see feature1.html and index.html. All right. So someone was asking me, what is the head pointer and everything? So let me go ahead and show you git log again. So if we do git log, we can see that there are different pointers to different commits. So first we have two commits, that is added a controversial opinion in file and created a new file called index.html. So this is our first commit, second commit, and third commit. Now the third commit happened only on feature 1. But why do we see master also over here? So we see master over here because we merged the two files. So this means that the master is now up to date. It is up to date with all the commits that have happened, not just feature 1. Now even master is up to date. But the thing is, our origin, right? Origin is our remote repository. So if we come back and if I refresh over here, I can still not see any new changes happening. I still see the old same code. And if I come back, I don't see any new branches also. So this means that my origin is not up to date. It's not up to date with the new changes that has happened. So this is basically a pointer. Head basically gives you the pointer to the latest commit that has happened and which all branches are up to date. Now if I create a feature 2 branch, it will also be up to date because I am going to be creating it from my master branch. And remember, whenever you create a branch from a certain branch, it will copy all the elements, even the commit. All right. So if I do a git branch feature 2, and if I do a git log again, you guys can see feature 2 is now up to date also because it will also have all of the things. Feature. All right, so one second. If I do an ls, you guys can see feature1.html, index.html. Now let me go ahead and show you what happens when we create feature2.html. Now what will happen is the developer 2 will basically stage this code. Basically, once he stages it, he will go ahead and commit it. All right, so he's committed it. Now if you do an ls, you see feature2.html over here in feature 2 branch out of the 3 branches we have. And if we go to git checkout master, if we go back to master, And if we do a git log over here, or let me do a simple ls, you guys can't see the new file that we had created, right? And if I do a git log, you guys can see that the, okay, so yeah, so yeah, so basically you can see master and feature 1 added to the feature, but we still don't have a feature 2. So let me go ahead and merge this, git merge feature 2. And if I do a git log over here, all right, so now you guys can see a much better idea. You can see that the master, right? We merge feature 2 to master. So it has the new file and all. If we do ls, we can see the new file over here, feature2.html. But feature 1 does not have that commit, right? That's why it's below. It's still not up to date. All right, but we don't necessarily need it to be up to date. It's just, it shows us where each commit is pointing to. Okay, so it tells us which branch is up to date and stuff. All right, so now let's go ahead and push this, git push origin master. We will reflect all the changes. And if we come back, if I refresh, all right, so okay, you guys can see the changes that I've made over here. You can change from master. Okay, so we have, oh yeah, so let me just show you one thing. So we did git push origin master. If you want, we can push other branches also. If I do a feature 1 push, so it will go ahead and push my feature 1 also. So while this is happening, I'll check all the questions. Please explain 2 commits with head. Can I get a full course on HTML? Yes, you can. Check out Great Learning Academy. To avoid conflicts, Ankit, what you have to do is you need to, all right, so if we refresh, to avoid conflicts, you have to make use of a tool called, yeah, you guys can see feature 1 branch over here. And in feature 1 branch, you can only see these things. All right. To avoid conflicts, you have to make use of a tool called vimdiff. Now, I will cover that in a future session because we already passed our time. Okay, so I hope you guys really understood. This is what I'm going to do. Right now, we don't have enough time to explain all the other concepts. Like we already did merging. Let me quickly explain rebasing. So rebasing is very similar to merging. The difference is that in merging, what you do is when you merge a file, right, you create a merge commit. And in that merge commit, you only have a history of the commits that have happened on feature 1 branch. You don't copy these commits over to the master branch. But with rebasing, what happens is you copy the commits themselves. You take the feature branch commits, you copy them, and you paste them on the master branch. All right. So this is done in projects where you have a lot of different people working, and you don't want merge commits. And Git workflow, let me quickly explain this also. So in organizations, right, you won't have these 3 branches and all. You'll have like multiple branches where you have master branch, where you have the develop branch, you have feature branches, you have release branch and hotfix branch. So quickly, feature branches where you write all the features. Develop branch is basically for storing all the features. Like once everyone's done writing the features, they'll merge it to develop, not to master. And once enough features have been added to develop branch, you will go ahead and review all the features. And once they're fine, you go ahead and put them on release branch. So on release branch, all the documentation and extra reviewing happens. And once the code is ready, right, it will just stay on the release branch until the time comes. Like there'll be a scheduled release where the code will be merged to master. And from master, it will go ahead for deployment. But when it goes for deployment, if there are any issues, you can go ahead and make quick changes using the hotfix branch. So this is Git workflow in simple. All right. Okay, so guys, quickly, if you guys have any questions, I'll give you guys 5 minutes. Go ahead and shoot these questions. I'll try to answer them. All right, so Ankit still has a question because I made a mistake. I had to reset 1 time after push. I want to see, okay, rebase history commit. So yeah, I hope you understood, Ankit, what the head is. Yeah, so it basically allows you to point to the latest commit. And if I show you git log again, you can see that origin and feature 1 are up to date because we pushed origin / feature 1 onto the this thing master, and we have origin master up to date because we pushed master to the origin. All right. Okay. And if you guys have any questions after this session, feel free to leave them in the comments. All right. So, any questions, guys? I'll be happy to, tell you the answer as much as I can. Why? Okay, so William asks, it's a good question. He asks, why merge to master if I can just commit the branch directly? Okay, so this is to create those layers I've been talking about, right? So you don't directly, in software development, right? You don't directly push to deployment. You need to have like a layer, like where after extreme rigorous reviewing has been completed, documentation has been completed, only then you push. So master is like something you don't touch all the time. You touch it only when you have to deploy things. Whenever all the experimental things or all the rough work will be done in features, and in develop you'll try to fine tune it, and once you're done fine tuning it, you will go ahead and put it on release, and from release you will put it on master. So you can directly push the branch, but the whole concept of having branches is so that different people can work on the same code. And if they work on the same code, right, so it becomes much easier to manage all of it when you have different branches. Not everyone keeps on merging to the master. Only certain someone merges it. Like whoever has access to the release branch does it. Okay, so someone's asking, can we use a rebase to resolve merge conflicts? So Sandeep, merge conflicts happen generally when you have people not knowing whether they're working on the same code or not. So if I have this index.html, right? If both the developer 1 and developer 2 working on these branches respectively work on index.html and they merge it to this particular master branch, then a conflict error occurs because there is changes within that one file. Now, to resolve a merge conflict, you make use of a tool called git. You use this method called git merge -d vimdiff. All right. Now, someone's asking how to roll back changes. So that's a good question, Prathamesh. So when you want to roll back a certain commit, right? So let's say I want to roll back added feature to file. So actually, no, let me just make another quick change. Nano index.html. I'll just give a space over here that counts as a change. All right, I'll go ahead and commit. All right, so if I do a git log now, you guys can see my head is over here to master. So I added a space. Now what if I want to revert this? So there is a command for that called git revert. I just need to go ahead and type in the commit ID. This is a commit ID. Whatever ID you want to revert, you just paste in the ID for that and enter. So when you revert, it will ask you to give a message also that you reverted it, why did you revert it, and all those kind of things. You can save it, and if I do a git log again, you guys can see that this reverts the commit, so this won't be included anymore. All right. Okay, guys, so that's it for this session. I really hope you guys understood something, and I really hope you guys understood how to work with Git. So those starting commands I gave you, right? You actually, if you're a hobbyist or if you just want to start learning code, that's enough for you. Then you can start working with the code. Okay. Okay, guys. Thank you so much for watching. I will see you guys in the next session.